Hello everyone, I am Teacher Michelle and welcome to another episode of Unang Math. In this episode, our lesson is the applications of this topic, Pythagorean Theorem. So in here, we will be solving some questions or problems as an application for this topic, Pythagorean Theorem. Okay, let's start with this first question. According to this, we will find the volume of a cone whose slant height is 13 centimeters and whose base area is 25 pi squared centimeters. So this is our cone. It's given that the slant height is 13 centimeters. It's also given that the base area or this circle is 25 pi squared centimeters. So this is 25 pi square centimeters. Okay, now the question is we are going to find the volume of this cone. Basically, to find the volume of a cone, we are going to multiply the base area, okay, times the height of the cone, and we will multiply this one by 1/3. But in here, height of this cone is not given. Take note, this 13 centimeters is not the height of this cone because the height of a cone must be from this point perpendicular to the base of the cone. So this is the height of this cone, perpendicular to this base. So if it's perpendicular to this base, then that means this is 90 degrees. From this center of this circle to this point, this is what we call the radius of this circle. So what would be the radius of this circle? Since the area of this circle is given, and that's 25 pi squared centimeters, take note to find the area of a circle, that would be pi times radius squared. So it means the radius or this length is 5 centimeters because 5 times 5, that would be equal to 25. So now we know that this length is 5 centimeters. Looking at this height of this cone, when we draw this perpendicular line or this height, we created here right triangle. And as I mentioned, this is 5 centimeters. Since this is our right angle, the opposite side or this side is the hypotenuse of this right triangle. So this length is 13 centimeters. Now we are looking for the height of this right triangle and also the height of this cone. So we can use here Pythagorean Theorem because two sides of this right triangle are given. Okay, so it would be 13 squared since this side is the hypotenuse. This is equal to 5 squared, okay, plus h or this height in squared. So if we will simplify, this is 169 is equal to 25 plus h squared. So we are going to subtract 25 from 169. So 169 minus 25, that would be equal to h squared or height squared. So this is equal to 144. And if we are going to find square root of 144, that's equal to 12. So it means height is 12. So this height is 12 centimeters. Okay, now that we know the height of this right triangle and also the height of this cone, we can now find the volume of this cone. So we are going now to use the formula volume that would be equal to the base area. So it's given that the base area is 25 pi squared centimeters. So we have 25 pi times the height, which is 12 centimeters. So times 12. And we need to multiply this 1 by 1/3. So times 1/3. Okay, let's simplify. So this becomes 1. This is 4. So 25 times 4 times 1, that would be equal to 100. So it means the volume of this cone is 100 pi cubic centimeters. Okay, let's move on to our second question. In here, according to this, in a rectangular prism, we will find the shortest path along the surface from vertex D to point F, passing through edge CG. Okay, again, this is a rectangular prism. It's asking us to find the shortest path or the shortest distance along the surface. So along the surface from vertex D, from this point or from this vertex to point F or to this point. But we have to pass through the edge CG. So to find this shortest path or the shortest distance, we are going to draw the net of these shapes involved in this path. We don't need to draw the whole net of this rectangular prism. What we need right now are those shapes that are involved in this surface. So we can draw here this rectangle and this rectangle. So this point is point B, this is point F, point C, this is point G, point D, and this is point H. Okay, the shortest path that we are referring here from vertex D to point F is this diagonal line. Okay, now, it's given that FG is 8 centimeters. GH is 4 centimeters. And this line or line segment DH is 5 centimeters. Okay, now, to get this length, we know that this is a right angle. So it means we can find this length using Pythagorean Theorem. And to find its length using Pythagorean Theorem, so let's say this is x. So we have here x squared, that would be equal to the sum of the squares of the other two sides of the right triangle. So 5 squared, okay, plus this length in squares. So 8 plus 4, that's going to be 12. So we have here plus 12 squared. So this is 25 plus 144. And this is now equal to 169. So square root of 169 is 13. So it means this length or the shortest path along the surface from point D to point F is 13. So we have here 13 centimeters. Okay, for our last question or problem, let's also answer this one. In this question, or according to this question, we will find the distance between the 2 points. Point A is 3, -2, and point B is -5, 4. on the coordinate plane. So in order for us to picture this distance, we're going to draw, we're going to draw coordinate plane, and we have to point where, or we have to indicate where are these points on the coordinate plane. So this is our x-axis and y-axis. So x-axis, this is our y-axis. Okay, the first point is point A. It has coordinates 3, negative 2. So 1, 2, 3. Y coordinate is negative 2, 1, 2. So it means this is our point A. So it has coordinate 3, negative 2. Okay, now what about the another point, point B? It has coordinates negative 5, 4. So 1, 2, 3, 4, 5. So negative 5. And then y coordinate is for 1, 2, 3, 4. So negative 5, 4. So this point. So this is point B, negative 5, 4. The question here is we will find the distance between the 2 points. So it means if we're going to connect these 2 points, what would be this distance from this point to this point? Okay, in order to find out the distance from this point up to this point, we are going to draw auxiliary lines. Okay, the first auxiliary line would be from this point perpendicular to this line. And another one is from this point perpendicular to this line. Okay, in here, this is a right triangle. This is a right angle. So if this is our right angle, that means this side of this right triangle is our hypotenuse, or the longest side of this right triangle. Okay, do we know this length? We can know. So here, 1, 2, 3, 4, 5, 6, 7, 8. So it means from here to here, this is 8. What about from here to this point? So 1, 2, 3, 4, and this is 5, 6. So it means this is 6. So using Pythagorean Theorem, we can now find the length of this hypotenuse. So let's say this is x. So we now have here x squared. That would be equal to the sum of the squares of the other two sides. So this is 8 squared plus 6 squared. 8 squared is 8 times 8, so that would be 64. Okay, plus 6 squared is 36. So x squared, that would be 64 plus 36, that would be equal to 100. So square root of 100 is 10. So it means from this point to this point, or this distance, is equal to 10. So in this question, the distance from this point to this point is 10.